Iconic software is used throughout the world to monitor, command, and analyze data center infrastructures. Iconic software, when configured for such an application, provides a powerful data center infrastructure management solution, which is also often called a DCIM. Looking at the menu, in most DCIMs we're providing, we're covering, we're monitoring and managing all of the electrical equipment, which would include the UPSs, the PDUs, and of course the switchgear. We're monitoring, analyzing, and commanding the chiller plant, providing all chilled water to the cracks, and then monitoring all the cracks, providing the cooling into the racks in the aisles. And finally, we're typically monitoring all the energy metering used to analyze where all the loads are going and the overall efficiency of the data center. Now, one of the most critical functions of a DCIM solution is the centralized managing of all alarms from all systems. So any abnormality, anything occurring of concern would come into the overall common alarm view. We can see all alarms as we're doing here, or we can filter off specific priorities, specific states. Now, any alarm that we see coming in, we can go through and quickly get to all information about this particular crack alarm. We can go to the detail for that crack. We can see the primary parameters. We can see the historical trends of all the data, all the temperatures, and so forth, so that we can analyze and diagnose the problem. And we can always get to all parameters, all details, all sensors that are being monitored from that particular device, and see all values. So that's the general workflow for many alarms, is to be able to move through and get to all information about that particular unit, get all the equipment data, and also from here we can also go locate it on the floor plan and see where the particular device is. That's the crack that's as the alarm that I just was looking at and selected from here. So always being able to quickly analyze and locate any alarm that's occurring. Now, when I'm not analyzing alarms, I want to be able to do quick walkthroughs to observe and monitor various parts of my systems. We'll start with the cooling system. Our first view of that is analyzing how well we're doing from a cooling standpoint. This is looking at a heat map showing the temperatures in my aisles. Now, typically, if everything is fine, colors will be transparent. But this is animated to show what it would look like if I have aisles that are overly cool and going to a bluish color, or overly hot, going to a reddish color, providing a heat map of my temperature gradients. Now, if, in addition to looking at the aisles, if I'm monitoring my temperatures in my racks, I can see the individual color maps of the temperatures inside the racks from the rack sensors, which are hot, which are cold. And of course, the color intensity, the darker the red, the darker the blue, is indicating how hot or how cold it is, how much it has moved away from set points. And then often we can also monitor humidity in the aisles. And that's another heat map we can look at. Now, looking at the equipment providing the cooling, obviously one of the most critical components is the chiller plant system. So I'm able to provide an overall system view. The Iconics graphics have unlimited resolution. So I can create an overall system view, and this view will automatically declutter and put in detail based on the resolution I'm able to see. So if I'm putting this up on a large screen monitor in the control room, which will typically be the case for this critical system, a lot more detail will appear. In this case, I'm recording this from my laptop, so I can zoom in, and as I zoom in, you're going to see more and more detailed information appear because I have the resolution to see it. And then, of course, I can move through the system and look at various parts of it and look at the current state. I'll just return to the full view. Now, also, I can pull in, as more and more, a chiller plant has usually quite complex control. It has tuning parameters to set up its sequencing. In this case, I'm going to all the tuning parameters, and I can sit there and modify these parameters if my security rights allow me to do so. I have various control cooling times set parameters that I can pull in for the cooling towers itself. I have a valve summary selected here to show the position of all of the valves associated with the chiller plant. So being able to overlay and pull in effectively every information needed to monitor this chiller plant and control it. It's an example of overall system monitoring. Now, the chiller plant, of course, is providing chilled water to all of the crack units. So I can quickly go do a quick walkthrough of all my cracks, pull in a dynamic list view showing all my supply air, return air, and my humidity being measured at each crack. See if I have any problems here. I do. I have one in an alarm. I have one. The fact that it's red because it's much higher than the set point. The arrow there is the set point. And once again, I can vector down to all the detail for that particular piece of equipment to see every parameter available on that piece of equipment in the trends. The other components for monitoring, if I on my electrical systems, if I want to go do a walkthrough of all my UPSs, there's my list view of all UPSs showing how close I am to the total capacity of that UPS, how much battery time I have remaining at the current load. Do I have any voltages peak dipping? And once again, from here, if I see anything that looks abnormal to me, being able to vector to all the detail for that piece of equipment to see the one line, see I have some alarms present, look at the trends of that piece of equipment, and this point details, all the parameters being monitored from that UPS. And lastly, bringing in my one-line diagram. Now, what we can provide is a dynamic and analytical one-line diagram that I can see my current state of any piece of equipment. I can see current energy use, how much current is currently going through any of these circuits. I can look at my 24-hour maximum currents, looking over, or we can set this to whatever we want if we want to look over time. Look at, what's my average. Quite often people will set a parameter to look at, what was my peak current in a circuit over the last month. Always looking to see if we're approaching any possible trip based on our current workloads. And of course, I can also aggregate the data to look at over any period of time, what's the total energy that's been consumed by this crack, by these particular PDUs, and so forth. Which tenants are using the most loads and most energy over time. So various analytical views of where my currents are, looking at where my peak currents are or getting to see if I have anything to worry about. and seeing where my energy is going over time from the one-line diagram. Lastly, doing energy analytics on that data. I'm looking at my current state, what is my KPIs, what is my efficiency, my PUE, where am I at on my total energy capacity, how close am I to my total capacity, also cooling capacity, and being able to look at a dynamic Sankey diagram showing at any point in time where's all my energy flowing, divided it down to the particular rack where it's going. And of course, I can also move back in time and look at the same data at various times. So that's a set of examples of how various customers have used our system for the DCIM application. Obviously, there's many different derivatives of this and in different configurations that different customers do, but I think this gives you an example of how all the various critical systems in the data center and how we're monitoring those. Thank you.